Hello guys, welcome back to Trigonometry Basics, and today we're gonna go through a little bit practicing with exercise with given sides, and we'll be just manipulating in order to find unknowns. Alright, so we'll be using the single one, this triangle. Okay, so it has right angle here. I hope you understand. So this is drawn to scale. If it's drawn not to scale, make sure you have this angle marked as the small square, or at least you put 90 degrees there. So you put 90 degrees, okay? And let's get started. We also touch similar triangles problem a little bit. We just simply, I'll show you where similarity comes from, and we explore nested triangles and see how the ratio of sides actually connect with the angle based on trigonometry, so that you can freely connect it with similarity for triangles. All right, so let's get started. Just this is sort of reminding for you. Okay, so we have, in this case, let's say right now we have angle theta in degrees, so Greek letter for angle, and we have, okay, so let's leave those sides as n, q, and p. So because as I told you, no matter which letters you use for sides, and sometimes in tasks and problems you'll be given different sides, different from what you have in the formula, so that causes sort of complexity and difficulties for students. Okay, so let's get started. For example, let's say you're given two sides, let's say n, let's take 9, and let's take q equals 4. All right, so we're given two sides, n and q, they're here, and we need to find theta. That's the first problem, find theta. Okay, so theta in degrees, obviously we need to connect them. Just remember how the sides are connected. So if you're not given any booklet on the test day, so guys, no problem, you just need to remember the single formula that I told you about. So I hope you memorize for sine, and for sine what we have. So this is height, right, because it's opposed to the angle, 90 degrees. So relating to this angle, this side P is adjacent, this adjacent side, and Q is the opposite. So we use relation opposite with hypotenuse and with angle theta. So in this case, we're given n and q, so that's where we're given hypotenuse and opposite. So just remember the basic relationship between opposite and the angle and hypotenuse. So by definition, opposite is hyp times sine of theta in this case. Okay, we've got angle theta. So what we know, just mark, actually might be helpful. What do you know? You know n and q. So in this case, you've got opposite and hypotenuse. All right, so you know them. And you need to find, in order to find angle first, you need to find sine theta. Okay, so sine theta works as the like integral component. So you can split sine and the angle. I told you in the very first video. So make sure you guys watch that, because that was the real basics, and actually the core of trigonometry is there. Now we're just practicing a little bit with sides and angles. All right, so let's find sine from here. So sine as the whole factor, simply as the factor. So how to find that? That's the result, the product, opposite, we divide by hyp. Okay, that's how it works. So we've got sine theta equals sum. Instead of opposite, we put q, it's 4, and we divide by 9. So what sort of check you can do? Right now, you probably don't know well sine, cosine, and other trigonometric functions. So make sure you can check that. So the checking point here is that sine of any angle theta is within -1 and 1. But in most cases, you will use positive values. So that's why you need to consider sine theta to be less than 1. So cosine theta as well has the same limitations. So when we go through sine cosine functions, probably that's sort of extended topic, or higher definitely. So I'll show you how each function works, how the value come up and how they come from, and only then you probably understand why the function is limited. So now just believe, okay? So that's your actually checkpoint. So you need to check when you figure out sine or cosine, you can check it. So for tangents, no limits. So for tangent, you don't have any limits, any specific limits, at least within like which values they are. Okay, so you've got a fraction first check is less than 1, so you check that and it's cool. So check. If you got 9/4, for example, by chance, you divided the vice versa, obviously your fraction will be improper. In this case, it will be more than 1. So you need to stop yourself if it's more and say, okay, hold on, sine is less than 1. That's your checking point. Okay, so next up. What do you do? So just remember 4/9, not like standard value. So in most cases, you'll be using calculator. So you saying, okay, we've got sine black box. So what's the input? The input is 4/9, and this is their number. So we want to get, according to our task, we want to find theta in degrees. So what we know? We need to know theta in degrees. All right, so what sort of black box should be there? Sine minus 1, right? Because input is a number and output is degrees. So it's inside. So how to get the arguments inside? Just remember about inverse function. So that's all about inverse functions. Okay, so how to work it out? You just take in calculator. So going, for example, if you're Android based, if your calculator is Android based, you just simply go to second set. Let me see that, how it works here on mine. You just go into the second set of the buttons because they are reciprocal functions, inverse functions. So you saying sine minus 1, you might probably see instead of sine minus 1, a sine. It means arcsine, so inverse. Okay, and you press on this button and you input the number. So your number is 4/9. Okay, and here's the result, 26 something degrees. So 26.387. So I round up to the p, so I'll get 39 degrees. That's my angle, and that's the result. So make sure your calculator is set up in degrees mode. So make sure that you can clearly see that results will be in degrees. If you have something wrong, obviously you set up for radians and then you need to switch back. Okay, so that's how it works. Now in this case, so may pause if you are not confident about how it works, but we go next. So I want to erase the O, because right now we're gonna use different parameters. All right, now let's say we want to find some sides, and in this case we're given not hypotenuse. Let's practice with Q. Let's take, we are given Q side, it's 4 for example, and we want to find hypotenuse. So hypotenuse. In this case, we should be given angle theta. Let's say we're given angle theta. Okay, 30 degrees. Okay, so we've got that. Q and theta were given. So theta and Q. Again, relating to the angle theta, we've got 30 degrees here, and we've got Q equals 4. So we need to find hype. Hype is here. So we set up the same equation. So opposite side, Q. Just right now, I'm just going to write it from scratch. And so opposite side, Q, 4, equals to hypotenuse, which is unknown, you multiply by sine theta because opposite through the sine. So sine of 30 degrees. Okay, so from where hype is simply 4 over sine 30. So what guys you think? For example, you calculating that. So you pressing the button on the calculator sign and you want to figure out, okay, so your input in this case degrees, so the result as output is the number. Yeah, it's always about number into degrees and back and forth, degrees into number. This is our case. So we've got sine 30. That's the first set, sine 30. And we got 1 over 2. So I know that's the standard value. So sine 30 is 0.5. Now you're taking 4 divided by 0.5. So 0.5 is the number. So hypotenuse in this case, 4 over 0.5, it's 8. So guys, in which way you can check your answer? So look, hypotenuse is the longest side, so it always should be more than any leg, any opposite or adjacent leg. So in this case, hypotenuse is definitely more than your opposite leg, and that's why it's your check in this case. So check, it works, so that's your answer. If it's less, for some reason, probably miscalculating, definitely you need to cease your working and try to roll back in order to adjust some parameters and recalculate. Okay, let's do a bit more complicated task in this case. So the same triangle, now we know, the following. So let's say we've got another angle. Okay, so we've got this angle now, and we know that this angle is x. So another angle is, let's say, 30 degrees more. So angle A is 30 degrees more than B. Okay, I even raise x. So that's your task. So angle A is 30 degrees more than angle B. Okay, you don't know angle itself. Okay, so next you're given this leg is 4 and this leg. Oh, and that's it actually. You need to work out P. So you're given that Q is 4, so find P. So find this leg. All right, so first of all, because you're not given angle, but in order to use trigonometry, again, that's about 2 sides and the angle. Right now, you're given only one side. So what to do? First, you need to establish the angle. So if you're given that angle A is 30 more than B, so you set up, let's say, angle X for B, and angle A is simply X plus 30, right? Because it's 30 degrees more. All right, so you know that the sum of all 3 angles is 180, or you can use the shortcut that X plus 30 and X should be equal to 90. So I'll put the full writings. Plus 90, no, it's 180. And if you subtract 180 minus 90, you'll discover that X plus 30 actually is 90. That's the shortcut. If you remember, just use it immediately. All right, so from where we can figure out that 2x is simply 60 degrees, so 1x is 30 degrees. Okay, so we established the value. Now we can remove unknowns and say, okay, that's 30 degrees, and this 30 plus 30, which is 60 now. Okay, so let's move next. We know all the angles. Now you need to choose, you can choose actually any angle you like. If I take, for example, 60 degrees as the angle, so I raise 30 because I need only one. So in order to find P, we have opposite side. In this case, 4 is opposite, this is adjacent to the angle 60. So what we can do, we can create the ratio opposite to adjacent is tangent by definition. So tangent. So tangent of your angle 60. Okay, so opposite is 4. Unknown adjacent is P equals to tan 60. Alright, so if you calculate tan 60, and it's better to do it right now, you'll get the value 1.73 something, because it's square root of 3 actually. This is standard value. So, and you've got 4 over P. How to find 4? Sorry, how to find P? You just crisscross, because 173 is over 1. So you do crisscross, so you swap 173 and P, this fractional equation. So you've got 4 over 1.73, which is P. Okay, so let's see how it works. P value is simply 4 over. So that's 4 over. Okay, you've got value 2.309. And that's your result. Okay, so guys, I hope you understand how it works. You just need to be more practicing, and you can have a chance to do it in the revision section for basics, for trigonometry basics. So make sure you just, after that video, you just go there and try to do it, or at least don't set aside for a long period of time. Just sit for a while and try to go through. In this case, you'll solidify your knowledge definitely. Alright, so remember I decided to explain you about similar triangles, similarity, and that's why we just go down and you see they're nested triangles. Let's say that's the base one, so the smallest one, and all the lines here, so where you can see all the lines here, all the segments BC, DE, and GF, they're all parallel segments, so you can mark with arrows in order to notify that they're parallel. Okay, so they're all parallel. In this case, so if you consider the smaller triangle, it's nested in the bigger one, and which is actually nested in another way, another one, so the biggest one. Okay, so what can do? Actually, this is a bit about exploration. So you can pause the video, try to measure the size of each side. For example, we consider about sides AC, let's put X, and BC, let's put Y. But because it's the first triangle, right, this triangle number 1, we can mark as X1 and Y1. So my goal is to tell you guys, by the way, I forgot to tell you that BC, all the segments actually perpendicular, they have right angles here. Okay, so what we're gonna do, because we have 90 degrees angle, we also have this angle common for all triangles. Look, indeed, we have ABC here, that's angle, let's say theta. So in this case, let's take C that equals, I don't know. We don't know the measure, right? We actually want to figure out the measure of this angle, and we need to establish that for all ratios is going to be the same. So, but it seems to me that this is about 30 degrees. Okay, that's my guess. So guys, try to measure and try to figure out this angle. So that's you need to do by measurements. Okay, so try to measure the size. So first we need to measure x1, y1. So the next couple is the biggest one, so from here to here, that's x2, and also DE is going to be y1, sorry, y2. Okay, and the last one, which is the biggest one, so from here to the last point F, which is simply x3, and you need to measure versus y3. So we're actually measuring couples, and what we're going to do next, we need to create the ratio. So what's ideal here? So actually you might be measuring those sides, but I'm just about legs. So we're just measuring legs for each triangle. And what we need to complete, we want to complete the ratio y1 to x1, y2 to x2, and y3 to x3. So what I'm going to say, we'll get everywhere, we should get the tangent, right? That's by definition, the tangent theta. Look guys, one more time, opposite to adjacent. So opposite to adjacent, opposite to adjacent. So okay, what we're gonna reach? We're gonna reach that tangent. In all the cases will have the same ratio. So if the tangent have the same ratio, what it means? It means that the angle actually the same, right? And indeed, that's the same for all triangles. So in this case, if we got the same ratio, all the triangles will be similar, okay? If we have the same ratio, we have all the triangles similar. It means all the angles inside will be the same no matter how big your triangle. So that's why if triangle is nested, it's about scaling, right? So you have the scale up from the first triangle to the third one. So you have the scale up transformation, just remember it. So no matter, the ratio of sides keep the same, and that's very significant. So ratio during scaling up, so it keeps the same. Okay, that's sort of observation guys for you and exploration here. Okay, that was a bit extra bonus. You can use it for your project. Maybe you can expand it to some interesting topics. Okay, so try to maybe play with sides, try to play with angles, maybe try to prove something. Just one more time, search in the internet and try to see scaling procedures, scaling transformation. Maybe you can create the whole project for your internal assessment for GCSE program. Hope you enjoy, guys. Don't forget to use calculator properly. That's the black box here, right? With their buttons. Don't forget how it works. If you got those two videos clear, I'll guarantee that you can go on the next level for trigonometry. If you can do that, if you revise that for practicing, definitely it's time to go up. So after that, you've been tuned up. Hope you like that. Don't forget to subscribe. Thank you for newcomers. I really appreciate your support, and peace.